Hello guys, welcome back to ptet.chemistry channel. So in this tutorial video, in fact in this lecture tutorial video, I'll cover a little bit to start off this ion and ionic bond topic. So this is a continuation of the ideas you have picked up from the previous topic, which is on atomic structure, and as part of this lecture tutorial, which will be broken down into small chunks as bonding itself is a huge topic. So this is based on the 2023 combined science syllabus, which is quite common across many of the combined science curriculum, or they call it double science curriculum, across most of the 14 to 16 years old chemistry content all around the world. So 14 to 16 years old are expected to know about atomic structure, which I already covered in the last topic. And having said that, so here candidates should be able to describe the formation of positive ions. So ions are not atoms, so ions are charged, and ions can be positively charged or negatively charged. So when your ions have a net positive charge, and when you form these positive ions, they are known as cations. And then when you have ions that are negatively charged, then they are known as anions. So these are the technical terms. When I mention cations, I mean positive ions. When I mention anions, I mean negative ions. Cations are positive ions, anions are negative ions. Alright, so that's basically the main objective that I'll cover in this tutorial video, and I'll leave the rest for another lecture tutorial in this series on structure and bonding. So talking about the formation of ions, as I said, an atom is uncharged. If an atom is uncharged, it's a result of equal number of protons and electrons. So when we did electronic configuration, we figure out that, let's say we draw nitrogen on your periodic table. Your periodic table show you as 714, and as I mentioned in the previous topic, as well as throughout the lessons and lecture tutorials, you must be able to put this into international format, which is what they call the nuclide notation, where we put the mass or the nuclear number on top left, okay, and then the proton or the atomic number at the bottom right here, okay, whereas your periodic table show you atomic or proton number on the top. This is what you write as part of international format, and this is how question will give it to you as well. Alright, so having said that, we can establish that this is proton number, or this is atomic number, and then the number on top there is mass number or nucleon number. So I could establish that there are 7 protons, and therefore there are 7 electrons. Electrons are negatively charged, 7 electrons, because in an atom of nitrogen, the number of electrons equal to number of protons. Okay, in terms of the number of neutrons, the number of neutrons is equal to the nucleon number minus the proton number. Nucleon is the proton and the neutron in the nucleus of an atom. If you know nucleon number, you take away how many protons there are, you will get the number of neutrons. So it's the neutron, number of neutron equal to the nucleon, or the mass number, which in this case is 14, minus the proton number, so there are 7 neutrons. So these 3 pieces of information are important, but we also talk about electronic configuration last topic. You can watch those lecture tutorial as well as the work you have finished prior to starting this topic. Alright, equal number of proton and electrons, because you have an atom which is uncharged, so the positive charge of the protons must be balanced out by equal number of electrons which have equal and opposite charge to the protons. Okay, neutrons are uncharged. These are all in that table of relative charges and relative masses that Cambridge or any other exam boards like to ask the 14 to 16 years old students. On to the next part. An ion is charged. Like I said, it's charged because you have unequal number of protons and electrons. Okay, remember the number of protons is the identity of the element, whereas you could gain or you can lose electrons and you will form ions which are charged. Okay, so what do we know? An atom is most stable when you have noble gas or group 8 electronic configuration. So this is an important thing. The valence shell is completely filled. Okay, so the outermost shell, the valence electron shell, is completely filled. That is when the atom is more stable. That's why noble gases or group 8 with completely filled outer shell has very stable electronic configuration. For these 7 electrons, you would have 2 electrons in the first shell and then 5 electrons in the second shell, because you have 7th electron altogether. So you have 2,5. This is in the first shell. This is in the second shell. So in this case, for nitrogen is in period 2 and is in group 5, because the period number, it tells you how many shells are being occupied with electrons, and then the group number tells you how many outer shell or how many valence electrons you have. 1, 2, 3, 4, 5. This is an atom, okay, where the number of protons equal to the number of electrons. If you want to go to a fully filled outer shell, then atoms of this element, this being a non-metal would like to gain electrons. So non-metal would like to gain electrons, and what you will get is you will gain how many electrons in order to go to a fully filled outer shell. So what we have here is 1, 2, 3, 4, 5. You can fill up to 8 electrons in the second shell. So I'll add 1 electron and I still have only 6, 7, 8. So now I have 1, 2, 3, 4, 5, 6, 7, 8. Now I have 2, 8. That means I have gained 1, 2, and 3, because originally being group 5, I had 1, 2, 3, 4, 5 valence electrons. In addition to the 1, 2, 3, 4, 5 which I originally had, now I added in 1, 2, and 3 to get a completely filled outer shell, because I want to become stable. So what happened is I gained 3 electrons. When I gain 3 electrons, my total number of proton does not change, because I haven't changed the identity of the element. It's still nitrogen. So what happened then is I gain 3 electrons, but I still have 7 protons, and plus 3 more electrons, I have 10 electrons. So what happened then is this will become a 3 minus charge. The most common mistake that a lot of students make is that when you gain electrons, you form anions, because you will have more electrons than protons, and electrons are negatively charged, protons are positively charged. If you have more negatively charged electrons than the positively charged protons, then you will get a net negative charge. You gain a net 3 electrons, therefore you get a net 3 minus charge, which are negative ions. This is called a nitrogen anion. Alright. On the other hand, if you have metals lose electrons to form positive ions, and we will see that in the next example. Okay, so cations is a result, it's positive ions, because you have more protons than electrons. Okay, whereas you get anions because you have more electrons than protons. Electrons are negatively charged, protons are positively charged. Okay, it will make more sense as we go through more examples. For example, in this case, we reinforce this idea. Metals lose electrons. You give away your electrons. You form positive ions called cations. Is a Y2 plus there because you lose 2 electrons, because plus there is a cation Cation means you lose electrons. Metal loses electrons. Here you lose 2 electrons. That's why it's a 2 plus charge as indicated there. For example, in this case, this is sodium. Sodium is a third period element. This is first shell, second shell, and this is third shell. So sodium is a period 3 element. It's a group 1 element. So what we have here is that the group 1 metal, the metal like to lose electron. Metal lose electrons to form positive ions. Metal tend to be on the left side, okay, towards the left side of the periodic table. However, of course, you have the big block in the middle. Those are called transition metals, and you will do more of that another time. But typically, in these beginning stages of your year 9 chemistry lessons, you tend to think about group 1 and group 2 definitely, and to some extent, okay, to some extent group 3 also, but not all the group 3 obviously. Alright, things like aluminium, for example. So aluminium is a well-known metal. It's a lightweight metal. So all the group 1 are metals, all the group 2 are metals. There are some metals in group 3 including aluminium, but not all other elements in group 3 are metals. Just a few to keep in mind as part of your vocabulary. Alright, so the sodium atom loses how many? Loses 1. Why only 1? Because you only have 1 electron in the outer shell. And once I lose this one, I will have a fully filled outer shell, but I will no longer have 3 shells. I will only have 2 shells because the electrons in the third shell is gone. So that means the third shell is now empty. And if the third shell is empty, you only have 2 shells that are filled with electrons. Is a plus 1 where we don't show the 1. It's a plus 1 because we have lost an electron. We have lost 1 electron. Okay, now you have a charge. This is Na plus. Is Na plus ion. It's got 2 8. It's got 2 in the first shell. It's got 8 in the second shell. So based on what we have said, magnesium atom. So magnesium, the symbol is Mg. It's from period 3, the third row in the periodic table. And that will mean there will be 3 shells, 3 electron shells being occupied. So you could draw first shell, put it in Mg. There will be a second shell, and there will be a third shell as well, because that's what period 3 means. The period number, the number of the period in Arabic numeral, as I mentioned in atomic structure lecture tutorial and all the exercises before. The period number tells you how many shells are occupied by electrons. And then looking at the group number is 2, so that means there are 2 valence electrons, 2 electrons in the outermost shell. So going from hydrogen, filling up to the third period, hydrogen, helium, then lithium, all the way to neon is 8 electrons in the second shell. And after filling all that, you are still at neon, okay, which is 2 8. And then you need to fill in the third shell, so 2, 8. That's the maximum in the second shell. So what happened then is you fill the third shell, and the third shell is the outermost shell because you're in period 3. So there are 3 shells being occupied. So the final third shell, the outermost shell, will have 2 valence electrons. So it'll be 282. So how do we look at these? We look at these in terms of the first shell, the second shell, and then the third shell is not fully filled. The third shell is not fully filled, and it is a metal. Magnesium is a group 2 metal. Metal loses electrons, so it loses electrons. It loses the outer shell of the valence electrons. How many electrons does it loses? It has 2 valence electron. So what it does is it loses 2 outermost shell electron. It loses 2 valence electron, which is 1 and 2. So after that, what we will get is we will get only 2 shells now, because the last outermost shell would have been gone. So now you only have 2 and 8 in the second shell. So we write 2, 8. This is an atom with no overall charge, where the number of protons equal to number of electrons, as I said. This one, you have lost 2 electrons. Just now, you have 12 protons and you have 12 electrons. Here you have 12 protons because we don't change anything in the nucleus. That's why it's still the same element, magnesium, 12 protons. But what instead we have is 10 electrons, because 2 plus 8 is 10. This is electronic configuration, how these 10 electrons are distributed, how these 10 electrons are arranged in shells. You have lost 2 electrons from the atom to the ion. That's why now you have a net positive charge, because you have more protons than electrons, and you have more of the positive charge by 2. That's why you have 2 extra positive charge. When you lose electron, metal lose electrons, you get positive ions. It's called cation. So this is called Mg2 plus ion, which is also Mg2 plus cation, which are positively charged ions. Moving on to the next one. So aluminum is just in the same shell as magnesium. So I'll have 2 and then 8 in the second shell. And then I'll have 3 in the third shell, because aluminum is a period 3 element. Period 3 elements would mean 1, 2, and 3 shells being occupied, 3 shells being filled with electrons. It's a group 3 element. Group 3 elements means there are 3 valence electron, 1, 2, and 3. Valence, V-A-L-E-N-C-E, means outermost electrons, outermost shell electrons, meaning how many of these electrons are in the outermost shell. So there's 2, 8, 3. Metal loses outer shell electrons, so it loses the 3 valence electrons, the outermost shell electrons. And what you will get is, I'm just going to copy this, and then I will remove the outermost shell electrons. I remove those 2 and this one. Okay, now what I have is, I have lost 3 electrons. Now I have 2, 8. I go from 13 electrons total, 2 plus 8 plus 3, 13. Now I get 10 electrons, which are arranged or distributed among the shell as 2 in the first shell, 8 in the second shell. 2 plus 8, altogether there are 10 of these crosses, 10 electrons. But previously, I have 13 protons, because aluminum atomic number is 13 in the periodic table. So you still have 13 proton number, but you now have 10 electrons. So what you have now is, you have a 3 plus charge, because you have more protons, which are positively charged, than the electrons, which are negatively charged. These are from your atomic structure, the previous topic, which candidates are expected to be able to appreciate and understand, and be able to state the charges, the relative mass of protons, electrons, and neutrons. Okay. Onto the negative ion, so the nonmetal will gain electrons to form negative ions called anions. So just now, we lose electron and we'll get a positive charge. When we gain electron or we'll receive electrons, we'll get negative ions, which are negatively charged ions called anions. The number, whether it's -1 or -2 or -3, indicates how many electrons have been gained. Alright, and we draw the electrons being gained by using dots in order to show that these electrons are different from the crosses. They are the original electrons of that particular element. Alright, and this particular atom, it started out with 1, 2, 3, 4, 5. It started with 5 of these crosses in the valence shell, and that is not completely filled for the second shell. This is the first shell, it's completely filled with 2 electrons. Second shell has 1, 2, 3, 4, 5. So what you do is, you will gain 1, 2, and 3. 5 plus 3 give you 8 electrons in the second shell. It's completely filled. That's why we gain 3 electrons. That's why it's a 3 minus charge there. And seeing here a specific example, so fluorine is definitely not Na, you can forget about that, it should be F. And then fluoride ion is not Na plus, it should be F minus. When we say minus, it means -1, because when they don't show the minus or they don't show a plus, it means zero charge, such as this atom. This fluorine is a second period element, so there are 2 shells being filled, and then there are 7 outer shell electrons, 1 2 3 4 5 6 7, because it's a period 2, and then it's a group 7, and these are all from your periodic table available for free. You gain 1 electrons because 7 outer shell electrons. When you gain 1 extra one, which you draw with something else other than a cross, okay, and then you have 8 electrons in the outer shell. Now you have a fully filled valence shell. Valence refer to outermost. Valence refer to outermost, and Cambridge will use either of these terms interchangeably. Sometimes they use this, sometimes they use that. So you got to know what is going on. And all of these, eventually you will have to know the formula of these ions, common ions as expected, by knowing your periodic table, of course. Moving on to real example, so we are oxygen atom. Oxygen is in period 2 and is in group 6. So can you imagine 6 outer shell electrons would need to gain 2 more, because 6 plus 2 equal to 8 electrons in the second shell, and that is completely filled or completely occupied second shell. So there's oxygen. First shell has 2 electrons. Second shell has 1 2 3 4 5 6, so there's just 2 6. First shell, second shell, so there are 2 period. Sorry, I mean they are in period 2, so there are 2 shells being occupied by electrons. Group 6, 6 electrons in the outermost or the second shell here. 1 2 3 4 5 6. What happened then is you want to gain 2 electrons because you want to get to a fully filled outer shell. So what we do is we show the original number of electrons, which are 6, and then what we do is we show by using a dot other than a crosses in order to show there are 2 electrons, 2 other electrons that are not originally yourself, and you will get a negative charge. You will get a 2 minus, which means a negative 2 charge because you gain 2 electrons. Just now you have was oxygen. Oxygen, the atomic number is 8 protons. That's why the atom has no charge at the beginning of the lecture, if you follow closely. Now you have ion. In fact, what you have is anion. Anion is negatively charged. And the reason for it is because you still have 8 protons. It's still oxygen and oxygen. You do not change the nucleon. You do not change the number of particles in the nucleus. All you're doing is you just lose electrons. Electrons are in shells. They are not in the nucleus. They are from the first syllabus statement in atomic structure, where candidates are expected to describe the structure of an atom when electrons are in shells. Okay. Now you have 10 electrons, because you have gained 2 extra electrons. Atom gain 2 electrons. That's why now you have more electron than proton. That's why you have a minus charge. You have a -2 because you gain 2 electrons. You have 2 more electrons than the number of protons. You have a net 2 minus charge. Last but not least, let me just finish this off with nitrogen. As usual with this lecture tutorial, you can just pause and actually or rewind and then try some of these yourself, okay, because there's nothing better than you trying out things on your own. So with nitrogen, you are in group 5, you got 5 outer shell electrons. What you'll do is you gain 3 electrons and you will get to a fully filled outer shell. So there's 2 in the first shell, and then put in my original 5 electrons in the second shell, and then I put in a dot, dot, and dot, because 1, 2, 3, 4, 5 originally in the valence shell, because the group is group 5. Group 5 Roman numeral mean 5 valence electrons, 5 electrons in the outermost shell, okay? and then I gain 3 in order to get to a fully filled second shell. So now I gain 3 electrons. I will have a 3 minus charge. This is called a nitrogen anion or nitrogen ion, and this is 2,8. This is also 2,8. Both of them have a fully filled outer shell for the ions, but then they do so as a result non-metals, oxygen and nitrogen non-metals, as well as group 7 non-metals. They will gain electron to form negative ions, the charges of which depend on how many electrons you gain exactly. So in this, just to summarize these lecture tutorials, we have talked about metals. Metals like to form positive ion. Metal will lose electron. Metal lose electrons. When metal lose electron, they will form positive ions. I've tried to make sense of it in terms of counting the number of protons and electrons, something you expected to be able to do from your previous topic on atomic structure. And then negative ion, the same thing we did was counting the proton and the electron number. Non-metal likes to gain electron, and then you will end up with more electrons than the proton. That's why you have a net negative charge. In essence, metal lose electrons, they form positively charged ions. Cations are what you call positively charged ions. Now this is anion because these are negatively charged ion. It's called anion. And they form as a result of non-metals gaining electrons to give you the negatively charged ion called anions. Alright, that's it for this lecture tutorial. Catch up more on another tutorial video on the work. It's called work 1 for this combined science chemistry on structure and bonding, where there will be exercises on testing or assessing this kind of knowledge gained from this lecture tutorial. Thank you for watching, and I'll see you in the next tutorial video where we'll talk more about ionic bonding next time. Alright, so follow me at ptet.chemistry on IG, Facebook and Twitter if you use this social media platform. And yeah, I mean, subscribe to the channel if you benefited from the work that I've done with the channel, and share the channel widely with all your friends, your chat or study group or Discord group or whatever group you have, and your juniors and the seniors from school if you think this will be useful for them as well. Alright, thank you for watching.